Good afternoon, ma'am.
Good afternoon. Is this audible? Anushka and Imad, right?
Yes, ma'am.
Yes, ma'am.
Alright. So the class started late. Meeting was not getting started. No, so it's a very short time that we have. Now after 10 minutes, your main batch will start. So let me just introduce you what we are doing currently. Before that, just tell me one thing, one by one. Anushka, you tell me first. What's the current physics lesson going in your school? Like right now, it must be your vacations that must be going. And before the vacations had started.
Yes, ma'am. Now we have got our summer vacations going on.
Yes,
So the
yes, that
school
I
will be
understand.
open on
Before the
15th.
vacations, yes, yes. But which lesson was going?
Ma'am, we were on the 4th chapter, that is moving charges in magnetism.
Moving charges. That has been completed, or were you in the middle way?
In middle, ma'am.
In middle. And what about you, Imad?
Ma'am, same. We are
Same
just
school.
same. We
Okay.
just started with motion in a magnetic field, like same chapter 4.
Okay, chapter number 4 was started. Fine. So then doing current electricity, this will be beneficial for you only. Because we are just doing the circuits portion is left. Rest of the parts we have completed. So some of the portions you both and with some other students, you can get a proper backup. And with some of the topics, what you can do, you can be provided with a recorded video lecture that has already been covered in this batch. And I think this weekend, not this weekend, but after next weekend, just a second, give me a second. So I was saying some topics, what we can do, we have a proper class for it, and some topics you can be provided with a video lecture of the same batch which we have studied. So in current electric current, we have already done all these basic topics. Resistance we have completed. We are done with resistivity and all these topics. Now we are on the circuits portion. So I'll brief you with the circuits only. But first tell me, is your concept of potential and current, all these basics are clear? Yes or no?
For me, ma'am, it's little bit difficult for me to understand.
Difficult. So Imad, what about your first two lessons? Chapter 1 and chapter 2, are they clear?
Yeah, those are clear, ma'am. Just because sometimes I just get confused, I just go through them and revise them. That's it.
That also I'll send you. Not only this chapter, because the previous chapter is also the chapter 1 and chapter 2. That also I'll send you. But obviously that video lecture only I'll send you. Like I have started sending the important topics. For example, first is electric field. Then you can see the whole lecture. Then after that Gauss theorem, and in this manner. Fine. So let me tell you just for today's class, because 1 or 2 classes you have to bear. We have started with series and parallel combination. And Anushka, what about you? First 2 chapters?
Ma'am, I just want to know that is this the first class of physics or second class? Because I don't think I joined the first one.
Yes, you have not joined the first class. Yes, this batch started last week before. So we are actually in the middle of this lesson. That's why we are in the middle of this lesson. But no worries about it. We can arrange a class for you separately for the backup for all the topics that you have missed in this batch, because this batch is a new batch, but some of the classes, I think 4 classes you have missed from the starting portion. Yes, I think 4 classes you both have missed. So those 4 classes, what you can do, you can take the videos also, because video lecture will be the same. Or some topics, or you can do one thing, you can watch the whole complete video. Whichever portion you're not able to understand, by seeing the video you are having your doubts, then you can ask me it separately. On the WhatsApp group also, I'll connect you both. There's separate WhatsApp group for boys and girls, so there you will be connected. So there also, anything if you want to ask, you can ask. Everyone is there on that group. Right? See, series and parallel combination of resistors. Potential of a cell, we know. Potential is what? Electric field is what? Let me just brief you with electric field. Electric field is space around a charge where what happens? Electrical phenomena, electrical properties can be experienced. Like if a positive charge is there, then there will be a certain space around this positive charge. What happens around the space? If you bring another charge, you will be able to see either force of attraction, force of repulsion, depending upon the properties and the polarity of the charge. So this space is known as what? This space is known as electric field, and it's a vector form. Now, the same thing in scalar form, that is known as potential, electric potential. So electric field was discussed in chapter 1 and electric potential was discussed in chapter number 2. So that you will see the details and everything, how questions come. Even you can take the assignments from me, you can take the test papers also that have been covered for first 2 chapters. Right now in this batch, no test has been started. So test will be there, but you will be able to cope up by that time. And then from magnetics, you will be having a fresh chapter with all of us. Fine. So in this, what basically you have to understand, and electric current is what? So potential is one thing. Electric current is the flow of charge, rate of flow of charges, amount of charge that flows from a wire through a wire for duration of 1 second. That is electric current. Now V is proportional to this potential that is applied across the terminals of a wire. This whole quantity is directly proportional to the current. Whatever current flows through a wire, no, the potential that is generated, it is directly proportional. Now, how do you remove the proportionality sign? Whenever in mathematics you have to remove the proportionality sign, you put an equal to with a constant. So here also we'll put an equal to and a constant, and the constant term that you get here is R. So the formula becomes what? The formula becomes V is equal to IR. V is equal to IR this is known as Ohm's law. It's a very important law and it's a very easy law. Very easy law. Easiest law that you have. V is equal to IR. Questions are also direct, that I'll help you with that. So V is equal to IR. Now this quantity that we got, no, this constant, this is known as resistance. The resistance is what? It's the opposition in charges that are. Whenever charges are flowing in a wire, through a wire, whenever charges are flowing, what will happen? Due to the positive ions that are present, due to the other charge particles that are present, due to the walls of the conductor, there will be certain resistance to the flow of these charges. So that opposition that occurs to the flow of charges, that is known as what? That is known as resistance. So potential, current and resistance, these three quantities are important for you to understand the series and parallel combination. May I know who is this? Someone has joined. Laya?
Yes, ma'am.
What's your name? How do you pronounce it?
My name Laya.
Laya, no?
Yes.
Okay, fine. So you're also in class 12, Laya?
Yes, ma'am.
Okay, so what about your syllabus? What about your physics syllabus that is going in your school? In which chapter you people are studying?
We just started chapter 3, current electricity.
You've
chapter.
just started. All right.
Yeah.
So Anushka and Imad are also here. So I was just telling them regarding how the backup will be given. Because here we are almost towards the middle of this chapter. We are just doing the circuits. In the last class also, we have started with circuits in this batch. So basically, how will the backup be given? That all of us can at least arrange for a class. We can have a class for it. Otherwise, what you people can do, I'll be sharing my video lectures with you. Recorded videos are there in the class only that have been recorded. So that also you can see. Whatever suits you, whichever video you think is not sufficient, you need a class for that. That can be arranged. And this way only backup can be given. And not only of this lesson, current electricity, the previous lessons too. Chapter 1 and chapter 2. So just get yourself added on the WhatsApp group. Laya, Imad and Anushka. Right?
Yes, ma'am.
All right. Yes, so I'll repeat once. These three quantities are very important for attending today's class. Current, potential, and resistance. These are three quantities that will be continuously used in today's class. Now, current is what? Current is the rate of flow of charge. In basic layman terms, you people are aware of current. So, if you have a simple wire, no, a basic simple wire like this, amount of charge that will be flowing through this wire, that is known as current. The amount of charges that flow, that is known as current. Potential is what? Potential is basically a scalar form of electric field. It's a space around the charge where you can experience the electrical properties, but in scalar form. Scalar and vectors, I hope you people are aware of. Vector quantities are those quantities that have a magnitude, they have a direction. Scalar quantities just have the magnitude. They do not have direction. But also one thing you should remember, that this topic, no, electric current. Electric current is the only scalar quantity that has a direction as well as a magnitude. Are you people aware of this? Current. See, in case of electric current, what happens? In case of Imad, are you saying something?
No, Mama.
So in case of electric current, what happens? It's the only scalar quantity that has a direction because it does not obey the vector laws. That's why we keep it under scalar quantity. So first thing is current. Second thing is potential. Third thing is resistance, which is given by Ohm's law. Ohm's law is very helpful because all your questions will be solved with it. It's a very small law which says that potential is directly proportional to current, and the constant that we get here is the resistance. So V is equal to IR. This is the constant term that we get. V is equal to IR. Here, the constant is resistance. So you will be having a separate class on resistance and resistivity that we have already studied in this batch, but I'll share the video lecture today only. All right, so in the last class, Asa, you were there, no, in the last class when we started with the series and potential. All right. Now, regarding series and parallel combination of resistance, this is very important. Why this topic is very important? Because this is not only included in your current electricity. The series combination and parallel combination, these are combinations of resistor as well as these are combinations of capacitors. So this is easy. It's easy, but there are certain cases where you will not be able to identify whether it's a series combination or it's a parallel combination. So there are certain techniques to identify whether a combination or arrangement of resistors are in series or arrangement of resistors are in parallel. Also, when you will reach alternating current, there you have inductor as well. So at the end, what happens? You will be having resistor, you will be having capacitor, you will be having inductor, and there will be combinations of all these. Fine. So this is simple to understand, but main thing is that how to identify whether it's series or in parallel. First, remember one thing. Whenever there is a branching in the wire, current always divides. Whenever there is a branching in the wire, current keeps on dividing. Now, what is meant by branching? Branching means if a wire has been divided into two parts or a new wire has been connected. For example, like this. See this. This was a main wire that was coming. What happened? Here the wire got branched into two equal parts. So this is known as branching. Now these are two different wires. So if such a case occurs, no, you are able to observe that there is a branching that has occurred. So it means what? It means current will definitely divide. Fine. It means that current will surely divide, but potential remains the same. One point is this. Clear? Abdullah, you are in class 11, no?
No,
12th class?
12, yeah.
Okay. Fine.
Is this 12 physics?
Yes, it's 12th physics. It's 12th physics. Fine class. So in series combination, what happens? So series combination, how is identified? Okay, before that, so one point is clear. If a branching occurs means like this was a wire. At this junction, the wire got divided into two parts. So current will here for surely divide, but it won't affect the potential. First point is this. Secondly, so when do we say a potential divides? If you have any material in your, or any breakage between the wires. For example, if I say this was a wire that I had, and in between I had connected a resistor. I had connected a resistor in between the wires. So what happens? Potential at this edge and potential at this edge changes. Means because of any device, the potential changes. Be the device an inductor, be the device a capacitor, be the device a resistor. Whatever device gets inserted, your potential values change. Before the resistor and after the resistor, there is a change in potential. Clear, class? But all these devices do not affect your current. Current gets only divided when there is a branching. How that occurs, that we'll see. Now, in case of series combination, how to identify series combination? Every time you won't see all the resistors are lined together, that so that you can easily identify whether it is series or parallel. Even if resistors are connected together, you just have to see the branching. It can occur that there is a resistor connected like this. This is known as branching. See, the wire has divided. So it means both these resistors are now connected in parallel. All right, so by this you can identify. So if current remains the same through each resistor, we say they are connected in series. If potential remains the same, we say they are connected in parallel. Now, series combination, the derivation that we had done in the last class, before you people had joined, in the last class you were not there. I think from here, students who are present, I think only Asta was here. Rest of the students are new. Abdullah, Anushka, Imad and Laya. So in case of series combination, potential through all the resistors are different. So right now you students need not note down anything from here. I'll tell you when to note down, because these topics have already been missed by you. So by the video lecture or by arranging a class, I think one class is needed for all of us, for even us. The initial portions were missed by you also. So just a second. So we have to arrange a class for that. So the timings that I'll discuss with you. Now, tell me one thing. If potential is different, so I can add all the potentials. That's why I'm saying your Ohm's law is very important here. V is equal to IR. Do not forget this formula. In your board exams, in class 12, or even in your entrances, a very easy question comes from Ohm's law directly, but application of Ohm's law is different. Application of Ohm's law involves, it gets involved in your circuits. Clear? So here potential is the same. So the formula of equivalent resistance is basically add all the resistance together. R1 plus R2 plus R3 plus R4 and up till nth. Just keep on adding all the resistors. That was series combination, and we had done a very simple question. Complicated questions and tricky questions we didn't do in the last class. So what happens to current through each resistor? Current through each resistor remains the same. So it's I1, I2, I3, whatever is the value, that value will be same. Why? Because we are considering series combination. And potential will be given to, through a single resistor, it will be given to V1 is equal to IR1. Second resistor, it will be given to IR2. Third, it will be given to IR3 and so on. So VNth will become IRNth, like this. We'll again do all these things. We'll again do, don't worry about it. So that's why I'm saying no need to write down all these. If anything is important, I'll let you know. When we'll do the new questions, no, all those circuits, then you like this. This is a series combination circuit. So here the current is same and equivalent resistance will be given by 5 plus 10. And this is the total voltage. So certain questions were given that we have done. That was series combination. In case of parallel combination, voltage remains the same. If voltage remains the same, it means branching has occurred. That's why current divided. Voltage remains the same, now current has divided. So a very two-line derivation is there. This derivation does not usually come in your board exam. Other types of derivations come. Here the net resistance is given by reciprocally adding all the resistors. 1 by R equivalent is given by 1 by R1 plus 1 by R2 up till 1 by Rn. Fine. Again, I'm saying don't worry about it, how to remember all these things, or everything has already been written and everything. We'll be again doing, you will be getting the video lectures for your backup classes. I'll add you all in the WhatsApp group as well. Just get yourself added on the WhatsApp group. There, everyone from class 12th batches are connected. So there you will be able to get it. Razan, with you are the timings fine? The weekend timings? Or were they clashing with some other subject?
No, ma'am, I don't think so.
It was fine, no, for you?
Yes, ma'am.
All right. So here they are reciprocally added. So current will be different this time. It will be given by V divided by R. Now again, from where did I write this? Again, I have written it from Ohm's law. I think Ohm's law, all of you must have heard it. Abdullah, what's the physics lesson that is going in your school? I have asked it from other students. You were not there. Before the vacations, your summer vacations had started. Abdullah.
Yeah, 1 minute, I'll tell you.
Yes, Abdullah? Okay, you can text me. You can text me whatever lesson was going. No, just let me know, because I want to know what's the current syllabus of your school. Otherwise, yes, Abdullah, I'm saying something.
Chapter 1.
Chapter 1,
Shark and field.
Chapter 1, Chapter 2, both have completed.
Yeah.
And what about this current electricity, Chapter 3?
No.
Okay, all right, fine.
Still.
Okay, it is fine. So right now your vacations are going, no, Abdullah?
Yeah.
All right. So I think most of your schools will start in September only. No, 4th September, 5th September, maximum schools, no?
August. 28th
August. 28th. Okay, Sunday, I think. So current is given by this parallel combination. So don't worry about the syllabus. We have to take 1 or 2 extra classes initially. Then once your backup is done, you will be in pace with the syllabus. Because at this time, we cannot start with chapter 1 definitely. If we start again from chapter 1, then all of your syllabus will be lagged. It will get piled up. So we'll start from here only, but we'll be keep on doing and completing our backup. Now, here if potential is asked, I'll show you with the help of question. Don't forget power right now. No need to go into the details of power. Like this. This is known as branching. This is known as branching. So if a branching has occurred, it means that both the current must have divided whatever current was there in the circuit. At one branch, it will go like I1. In the second branch, it will go I2, whatever is the value. I'm just taking randomly. So potential remains the same. What's the potential? 10 volt. So here also it will be 10 volt. Here also it will be 10 volt. So current R equivalent will be calculated by this formula. But reciprocally adding 5 and 10, that will give you 10 by 3. And then your total voltage of the circuit remains 10 volt. Voltage across each will be the same. Current across each we can calculate. See, current will be what? V divided by R1. So potential is 10, resistance is 5 ohm. Like this, I2 will be calculated by 10 divided by 10. In this manner, we have to calculate. So these were the basics question that we have completed. Now, in your exam, such basic questions will not be given. These kinds of questions are also asked, but certain questions, at least questions of this level, are given in your board exams. If the paper is easy, you can get the previous questions as well. Now see how to begin with this question. These kinds of questions involve basically reducing it. You cannot solve everything together. In the previous 2 examples, in the questions when I showed you right now, I had showed you what? In one line, you could get your R equivalent, either adding it directly or either adding it reciprocally. Right now, what you have to do, you cannot add all the resistors directly. Some resistors might be connected in series, some resistors may be connected in parallel. That you have to decide by looking. And if they are not connected in series, they are not connected in parallel, you are having trouble in identifying it. So there's a different Kirchhoff's law for it, and that's a foolproof law that we'll see later on. It's a very good, important law. It's just that it's very lengthy. So we always try to avoid it because an exam time duration is limited. If an exam specifically that is asked, then you people write it. But in general, we try to solve our question by identifying series and parallel combinations. So let me name these resistors. Let's say 1, 2, 3, 4, 5, 6. I have named all the resistors. Now, if I look at the first and second resistor, if I look at both these resistors, C class, here's a branching has occurred. It means both of these resistors must be connected in parallel. So current across them is different, potential across them is the same. At least this much thing or these many points must be in your mind before solving. That's why I have taken 10 to 15 minutes and some students have joined before that only. So that at least you are able to understand today's class, because without understanding those basics, you won't be able to understand. So it means both of these resistors are connected in parallel. Now, I'll make you notice one thing. How R equivalent will be given? Reciprocally adding. Why? Because 1 and 2, these are connected in parallel. So how will it be given? 1 by R plus 1 by R. That's the possible way to write when two resistors are connected in parallel. So what will be my answer? See, it becomes what? Here it is 2 divided by R. R equivalent, this was 1 by R equivalent. I want to know what is the R equivalent for both of these. R equivalent for 1, 2. R 1, 2. That becomes R divided by 2. Clear? Now one thing I'll tell you, class, that will help your question solving easier. It will make your question solving very much easier. And most of the time in the exam, these kinds of questions are given to reduce your time. If resistors are identical, divide the number of resistors, divide the resistance by the number of resistors. That will be equal to the equivalent resistance. For example, here too, just in case of parallel, if you see two resistors are connected in parallel and they are identical, what is meant by identical? Identical simply means two resistors having the same value. Here one resistor value was R, other resistor's value was also R. Had it been R1, R2, R prime, R double dash, then we would have not used this. Otherwise, instead of, doing this and solving and writing all this part, it's better if I write down the resistance value and divide it by the number. How many resistors are there? 1, 2. Am I getting the same answer? So this saves your time a lot. This will definitely save your time. R by 2, it will simply be R by 2. Now, for example, if 3 resistors are connected in parallel, and let's say all of the resistors have the value 30 ohm. An example I'm telling you, this is one resistor, this is second resistor, this is a third resistor. All these resistors have a value of 30 ohm. And these are connected in parallel. So instead of writing 1 by 30 plus 1 by 30 plus 1 by 30 and solving it, I can just write 30 divided by number of resistors 1, 2, 3. That gives me 10. So R equivalent for this parallel combination will be 10. In this manner, you can calculate. So this was just an extra thing in this. I'll be writing this as R12, not as R equivalent. R equivalent is the whole resistance across the circuit, across these 2 points AB. So I'm writing R12 here. So R12 is what? This is now both of these resistors have been replaced by a single resistor. That is R by 2. No more R1, no more R2. Now we have a single resistor which is connected instead of them, which is R by 2. So now how will my circuit look like? Will it be the same? It cannot be the same. I have just replaced it. So see how the circuit will now look like. This was the resistor. This is again a resistor. This is again resistor. Here I have a resistor. See, now you can compare it by this. One resistor, these three resistors, and this I have written. Now, instead of both of these, I am writing a single resistor. So these are what? These are R, A point, B point. This is not R. This is R12 now, which is R by 2. It's R by 2. Fine. So this was the third resistor, fourth resistor, fifth resistor, sixth resistor. So a little circuit has been reduced. Now see, nobody should note down anything right now. After I write it down, I'll give you sufficient time to note down everything. When I'm saying, just listen first. Now see, if you look at these two resistors, can anyone tell me how are they connected?
Ma'am, series.
Series, good, right. They are connected in series. See, it's a single wire only. Don't look at this point. We are not talking about this junction. Look at these two resistors. There is a barrier between them. There is no barrier between them. They are just connected with the help of a single wire. It's like I have this wire. I have made it into L shape. Will the amount of current be different? If let's say 5 amperes of current is flowing, I curl the wire. I make the wire as spiral, or I make it as straight. I make it into L shape. I make it into a circle. Amount of current, if it is flowing 5 ampere, it will be 5 ampere in this wire only, unless and until branching has occurred, wire has divided, new wire has added. Fine. So here also, as rightly answered by all of you, and Anushka and Astha, these are connected in series. Now, if they are connected in series, you can use your simple formula. Series adding in of series in case of resistors is very easy. In case of capacitors, it becomes opposite. Series becomes parallel and parallel becomes series, what you have studied here. But let's keep capacitors aside. Relation is easier when we have already studied. Right now, we have not discussed, let's not mention it. So now, R1, 2, 3. This will be what? Simply adding it. R plus R by 2. We'll do circuits only today. So at least you people get clear with the circuits part. Regarding what is resistance, detailing of resistance, what is resistivity, that is a separate topic that comes, and internal resistance, EMF of cell, terminal potential difference. All these topics are different topics. Fine. So even if you do not have an idea of what is the formula for it or what's the physical meaning of it, at least after today's class, you should be able to solve all the circuits. These things, yes, Imad.
Ma'am, sorry to interrupt you, ma'am. Actually, I was just told that this was a trial class for me to just join for 30 minutes. So
yes, you were not informed about today's timings. 2 hours class
no.
it was for you people, for the
No.
new students.
Okay, no. For me, I was just informed that for me it was a trial class and didn't join till now. They just said this may be a trial class for you to join just to get a clear idea. That's why I joined you.
Okay, so all of you were not informed about these two because it was earlier from today. Not for Razan and Astha, they already had it. What about others? Were you people aware, or you also were not aware about today's class timings?
Ma'am, I got the message in the morning itself about today's physics class.
No, were you aware about the fact that it was a 2-hour class for the new students?
Ma'am, not about the 2-hour class.
Not about the 2-hour class. So, Imad, do you wish to leave right now?
Yes, ma'am. Actually, I have to eat food. I didn't eat.
All right, Imad. Oh, fine, you can leave. If you were not informed, then it's okay. You can leave.
Thank you, ma'am. Sorry again.
So now series combination R and R by 2 are there. So what will happen? R and R by 2 are there. We can just add it. So it becomes 2R plus R divided by 2. That is 3R by 2. So this is R1, 2, 3. Now we have replaced R1, 2 and R3 with it. So now see how the circuit will look like. Let's reduce the circuit further. Now, here R, this is 4, this is 5th, this is 6th, A and B points are there. These are here. But right now, I do not have all these. I have reduced them into what? I have reduced them into 3R by 2. So here, instead of what was connected, instead of R3 was connected over here, no? So I have now 3R by 2 because this is R1, 2, 3. Now, can you tell me how are these two connected?
Parallel.
Parallel combination. Perfect. These two are connected in parallel combination. So R1, 2, 3 and R4, both of these are connected in parallel. How can you identify whether they are connected in parallel? Because of this. Here at this junction, the wire is dividing. See, one resistor is connected with the help of a wire, and this resistor is connected with the help of a second wire. Fine. So that's how you can identify it easily, whether they are connected in series or parallel. Now, if they are in parallel, we have to reciprocally add it for R1, 2, 3, 4. I'm just naming it as R1, 2, 3, 4 like this, so you are able to get it how many resistors have been combined. Just because of that, no other factor. Now, how R1, 2, 3, 4 will be? So it will be reciprocal of all these, so that becomes 2 by 3R plus 1 by R. So let's take, if we take the LCM, it becomes 3 here. That is 2 plus 3 divided by 3R. That gives 5 divided by 3R. Now class, always remember, students make this mistake often. They just leave their answers at this step. Fine. This is not your answer. You, whenever you're solving the circuits in parallel, you have calculated 1 by R equivalent. You haven't calculated R equivalent, the net resistance of the circuit. So net resistance of circuit will be what? You have to reciprocate it. Take the reciprocal. If 1 by R1 is given as something, then you don't have to write down 1 by R1. You have to write down R1. Here also, I have to write down R1, 2, 3, 4. So never forget to reciprocate it, because in one batch of class 12th only, here only, a test was conducted which had this topic, only circuits was involved. Most of the students forgot at the end to reciprocate. So by this, your marks will be cut. You will get the marks, reduced marks you will get for not writing the last answer perfectly. Fine. So whenever you're solving anything in parallel, be it a case of capacitor, be it grouping of inductors, be it resistors, just keep in mind whenever you have parallel combination means whenever you have these reciprocal combination. Like in case of capacitors, the series combination is this reciprocal addition. So there, just keep in mind, whenever this reciprocal things come, no fraction comes, just stay alert that I have to reciprocate it at the end. So here also, R1, 2, 3, 4 is what? This is 3R divided by 5. Now, so R1, 2, 3, 4, so many circuits have been reduced. Now the last step. Finally, we have reduced it further. This is the 5th one. This was the 6th one. Both have the value of resistance as R. Here, instead of 4th, we have now the full combination. So instead of writing R4, I can write it as R1, 2, 3, 4 because I have clubbed all of them. So now what we can write? I can write this as 3R by 5. All of you write me in the chat box how these 3 you people think are connected. Write me in the chat box. R5, R6 and R1, 2, 3, 4. How are they connected? Right, Astha, Razan, correct. Others? See, is it a single wire, or you think that other wires have been connected so that current will divide? What do you think? See, right, both of you are right, Asta and Rizan. It is all these three are connected in series. What has happened? Single wire was there, which had been converted into this U form, like this. A resistor had been kept at this edge. A resistor had been kept at this edge. A resistor has been kept at this edge. Single wire is there. In the previous case, you could see this additional wire, and here a junction was formed where current could have divided. Here you're not able to see anything like this. Here potential will get divided, but your current remains the same. So all these three are connected in series. Series adding is very easy. So this is ultimate the R equivalent, because now the circuit cannot be reduced further. All the resistors have been included. So R equivalent becomes R plus 3R by 5. So this becomes what? This becomes 5 is the LCM. So 5 plus 5, 10R, 13R. 13R, this much ohms is the R equivalent. First, tell me, is this question clear to all of you? Any doubts at any step, let me know. Even if things you're not able to understand from the previous topics, you are able to feel that this you are not able to understand because you have not attended the previous class or something. Just ask me that. Anushka, you want to say something?
No, ma'am. Everything is clear. This question is clear as well. No doubt.
All right. Good. So do one thing, all of you. Start noting this question from here. At any step, if you people stuck, just text me in the chat box. I'll answer you. Or if it's better if you unmute yourself and you're able to ask the question. At any step, you're not able to understand. Just note it down. I'll scroll it slowly. Just copy it down. See if you have understood it or not. Written class.
Yes, ma'am.
No, ma'am, 2 minutes.
Okay, I'm giving you 2 minutes. Just do one thing. When you all have written, just text me done in the chat box. So others have also written, except for Astha and Anushka. Abdullah, Laya, Razan. Done?
1 minute, ma'am.
All right.
Yes, it's done.
All right. So let's see some more circuits. So in this manner, we have to keep on reducing circuits. So like this only. Circuits can be added. So you have to combine series, combination, parallel, combination, series, and ultimately one thing will be left. And then it can happen only parallel combination is left or series combination is left. Now this is also important. Infinite series. This is important in the sense that if this question comes in your exam, then only few students will be able to do. But this chances of getting infinite series is a little less. Mostly you get questions which are based on finite series where you have certain resistors and certain devices connected. But obviously we cannot leave this topic. It's one of your major topics, because if it comes in exam, then you all should be able to do it. Infinite series means resistors have been added in a certain sequence, but until infinity. You cannot count how many number of 1 ohm resistors are added or how many number of 2 ohm resistors are added. I hope you people are aware of this symbol. This symbol is called as omega. This is known as ohm. So we write 4 ohm, 3 ohm, 2 ohm like this. This is the SI unit of resistance because of Ohm's law, obviously. Here in series is infinite series, what we have to do. Infinity till infinity means in the previous case, what happened? There were 6 resistors. We were able to count it 1, 2, 3, 4, 5, 6 like this. Here number of resistors are infinite. So if resistors are infinite, how will you get it? How will you get your final answer? So there are certain steps that are fixed and everyone gets the answer by that step only. And everybody follows that in every book that is written. First thing, step one that I've already written prior to the class is repeating terms. You have to identify the repeating terms. Repeating terms in the sense, if you are able to notice in this, see 1 ohm resistor, 2 ohm resistor like this, they have been connected. Then 1 ohm resistor, 2 ohm resistor. Again, I'm able to see this 1 ohm resistor, 2 ohm resistor. Are you people able to notice this 1 ohm resistor is connected like this, 2 ohm resistor, 1 ohm resistor, 2 ohm resistor. This sequence has been extended till infinity. So identification of this repeating term is important. It could have happened, there might have been a resistor here, but that would have not been included in the infinite this repeating term. Or there could have happened that here resistors would have been connected till infinity. So that would have become our repeating term. So a repeating term identification is very easy, that all of you can do. Just identify the repeating terms. Now, once you have identified the repeating terms, now how to proceed? Let's say whatever is my answer, whatever is the R equivalent resistance for this whole infinite series, let's assume that that is capital R. Fine, whatever is my answer, that is capital R. I have assumed it as what? It is capital R. Capital R is what? The whole answer for this. When I'll solve this entire infinite circuit, what should be the answer? I have taken it as capital R. Now, just tell me one thing, class. If I write down this whole circuit, I have reduced this whole circuit as R. This is my equivalent resistance. And this is infinity, answer of infinite resistance. If I add just one more repeating term to this, will there be any difference in this R value? I'll tell you what I'm saying. Here, this was the repeating term, 1 ohm, 2 ohm, fine. So this one additional, no, just one, not more than one, just one I have added to this infinite resistance. This infinite resistance, I don't know. I have assumed it as R. My answer, I have assumed that my answer is R. We take now in mathematics, let this unknown quantity be X. So like that, I have taken my resistance as R. But if I add this one just additional term, will there be any difference? It's like if you people have 1,000 with you, 1,000 is a big number. So if you people have 1,000, like infinity, instead of infinity, instead of this equivalent resistance, I'm taking 1,000. Let's reduce it to our understanding. If I add 1 to this, what will be the answer? 1,001? Yes, it is a little greater than 1,000, but approximately what will you say? It is 1,000. It's almost 1,000. So in a big number like infinity, this was just a small number, 1,000 that I've taken. In a big number like infinity, if you add a very small term like 1, what will be your answer? Infinity only. So in this, if I add this one more repeating term, so again the entire equivalent resistance, it will be still capital R only. It will be a little greater than capital R, but approximately we can say the answer will still be the same. Addition of just one more repeating term to this whole huge infinite term, will it make any difference? No. So just to do one thing, your repeating term, just put your repeating term along with your equivalent resistance, because now solving this resistor, this circuit, this is easier for us because this is definite, this is small, this is finite. Adding that infinite was difficult. So this small resistor adding this circuit, the solving of this circuit is simpler. It's easier than the previous question that we have done. Now we can solve this question and find out the value of R. But before that, you people have to identify that still R equivalent will be R. First, tell me, till here is it clear? Because understanding part is still this step only. Rest of it is simple mathematics that you've studied in your 10th, quadratic equations, splitting middle term and all these. Tell me, clear till here, class?
Yes, ma'am.
Others?
Yes, ma'am.
Clear now? All right. So, Abdullah, are you able to understand? Abdullah Ali?
Yes, ma'am.
All right, good. Now, so if you add one more repetition term, R equivalent should remain the same. Now, we can solve this. Solving this circuit is easy. Yes, class. Now this circuit is easier. This is simpler than the previous one. How are both these connected? R and 2 ohm resistor?
Ma'am,
Yes, Anushka?
Parallel.
Parallel. Yes, Asta. Parallel. They are connected in parallel. See, here is a junction. So whatever current must have flown through this wire, the different current would have flown through this wire. So this we have already done. This branching makes your series combination into parallel combination. So R and 2 both are connected in parallel. So let's solve it. Solving is not difficult. R is there, 2 is there. So R and 2 ohm resistors, these are connected in parallel. I hope you people agree. If there is any point that you people disagree that no, they should be connected in series, or this point you have not understand, just interrupt me there only. Otherwise, at the end, if you will try to ask, it may happen that you forget the doubt only. Now, if they are connected in parallel, so R equivalent, not R equivalent, let's name it as R1, 2. Let's name it as no, not 1, 2. 1 ohm is there itself. Let's name this as R dash. Let's name it as R dash. So 1 by R dash will be what? 1 by R plus 1 by 2. So this becomes, here it is 2 plus R divided by 2 multiplied by R. This is 1 by R dash. What will be the resistance? It will be 2R divided by 2 plus R. Now let's reduce the circuit a bit. See, from here, these two have been eliminated, only 1 ohm is left. Instead of both these 2 and R, I have a single resistor R prime with me now. So this is 1 ohm resistor. Here, this is R dash. This was AV point, no, I suppose. This was what? 1 ohm, and this is 2R by 2 plus R. This much is there. Yes, class, answer. How both both these are connected?
Series.
Series, perfect. Do you all of you agree with Astha?
yes, ma'am.
Good. So both of these are connected in series. It's a single wire that has been molded into U shape like this. This wire, like this. Single wire is there. You keep it like this. You keep it like this. Current will be same. No branching is there. So both of these are definitely, these are connected in parallel. Series. They are connected in series. Now this will be the R equivalent. This will be the R equivalent, which means 1 plus 2R by 2 plus R. So if I solve this, this becomes 2 plus R plus 2R divided by 2 plus R, which is equal to the R equivalent. I'm just solving this right now. So can anything be solved further? Yes, 2R plus R can be added. That becomes 3R plus 2 divided by 2 plus R, which is equal to R equivalent. Now, can any of you tell me what is this R equivalent actually? What should I write instead of this R equivalent? Anyone from the class? I have told you. Yes, Asta, try once.
Infinity.
No, we have reduced that circuit and we have assumed it something. What did we assume it?
R.
R. Now you've got it. The whole circuit, R equivalent was what? R equivalent was the equivalent resistance for the whole entire infinite circuit. And that we had already assumed it as capital R. Remember, from there we had started our calculations. Here, R equivalent, we have already assumed it R. This R was additional to us. The equivalent resistance of this also will still be R, that we have already argued and discussed. This will be still capital R. So instead of writing R equivalent, making it a different variable, I should write capital R itself. So this term can be written as 3R plus 2 divided by 2 plus R, which is equal to R. Cross multiplication, 3R plus 2, which is equal to 2R plus R square. So let's transport all the terms this side. This becomes R square minus R plus 2. This is equal to 0. Fine, class. Now this is a normal quadratic equation which you can solve it, get the value of the capital R. By this you have to solve it. So here it's also easy. This can be written as what? This is R squared. This can be written as minus 2R and plus R. Yes, this can be written as minus 2R and plus R. This also will be minus. See, this question got solved with the help of normal splitting the middle term. I hope you people remember splitting the middle term from your 10th class, from your basic maths. Or otherwise, if you get stuck and you are not able to solve such kind of question, that's why I'm saying chances of coming this infinite question is a little low. But be prepared. Do revise it once before you go for your exam. Otherwise is normal. The quadratic equation, no, you have b square plus under root d by 2a. The way you get values of x plus minus, like that you can solve. So here, if you take r common, what will be left from here? R minus 2. You take plus 1 common here, r minus 2 will be left, equal to 0. So r plus 1, r minus 2. One value of resistance is minus 1, other value of resistance is 2. Remember class, resistance can never be negative. So what's the final answer? This is rejected. Final answer is 2. So did you notice the entire circuit of that infinity? You were not even aware of how many 1 ohm resistors and how many 2 ohm resistors were connected. But still you can conclude to the fact that approximately your answer will be around 2 ohm. Definitely there will be a very, very, very slight difference in the actual answer because we have added one resistor, one term with to ourselves, but a very slight difference, because in this infinity, if you add one, where will the difference be? You will not be able to observe the difference. So I hope, is this infinite series clear to all of you?
Yes, ma'am.
Clear? Laya, is it clear to you? Laya Razan?
Yes, ma'am.
Razan? Your network issue is fine because I think in the meantime you got disconnected. All right, Razan. So start noting it from here. If at any step you're not able to understand, ask me. Others have also written. Abdullah, done? See, let's see some more questions. Now, this question, this is basically this arrangement. This is known as a Wheatstone bridge. You have Wheatstone bridge in your syllabus as well, Wheatstone bridge. Now solving of Wheatstone, I'll stop here. This is a very short topic. I'll do this and then we'll stop here. Fine. So just pay attention a little more to this, then we can have a break and then we can end this. Now, Wheatstone bridge is what? Wheatstone bridge is basically this arrangement where four resistors are connected in different arms of the wires, and from the middle of it, a wire goes and gets connected to the battery. Just arrangement is known as Wheatstone bridge because this bridge is formed like this. That's why it is called as Wheatstone bridge, just a name. But a speciality of Wheatstone bridge is there that these resistors, if they are in their balanced condition, then the solving portion of the question becomes easier. If it's a case of Wheatstone, right now this is a normal circuit. It's a normal circuit. How will it be a Wheatstone bridge? If a galvanometer or any device has been connected in the middle. Fine. So this arrangement is known as Wheatstone bridge. If let's say this is R1, this is R2, this is R3, this is R4. Remember class, we'll be proving this also. And if it is unbalanced Wheatstone bridge, then we'll see the question this way. So now, if R1 divided by R2, this is equal to R3 divided by R4. Then we call it as a balancing condition. And now let's name this as R3 and that is R4. Let's name this as R3 and this is R4. This R1, R2, R3, R4. Let's see over here. 10 divided by 20, is it equal to 20 by 40? 10 divided by 20 is equal to 20 by 40 or not? You have to check it. This is half, this is also half. So it means it's a balanced condition. If it's a balanced condition, if you are able to see R1 by R2 is equal to R3 by R4, then in the balanced condition, what happens? The potential difference across these 2 points, this becomes 0. And as the potential difference becomes 0, there is no flow of current across this branch AB. So if no current flows, it means, is this wire of any use right now to us? No current is even flowing. So just eliminate this wire. Just eliminate this wire means redraw your circuit without this wire if the Wheatstone bridge is balanced. If it is not balanced, then you have to apply Kirchhoff's law, and Kirchhoff's law we'll study later on. We'll study it in detail later on. You have Kirchhoff's law. Kirchhoff's law is included in your course, so you'll be able to study. So now how the circuit will look like? This was what? 10 ohm resistor, 20 ohm resistor. This was 20 ohm resistor and 40 ohm resistor. And the batteries, they're connected. This is just now how your circuit will look like. Tell me one thing, class. Laya, can you tell me how both of these are just connected? Just these two. Laya, only these two. Series, parallel, according to you. I'll help you with that. Just let me know. Series, perfect. They are connected in series combination. So these two are connected in series combination. It means R1, 2 will be what? Simply R1 plus R2, which will be equal to 10 plus 20, which is equal to 30. Fine. So this is R12. This is not R equivalent. These two. Razan, can you try how these two are connected? 20 ohm and 40 ohm?
Series.
It's perfect. These two are also connected in series. So here R34 will be equal to R3 plus R4, which will be equal to 20 plus 40, which is 60 ohms. Now, this is not your final answer. Why is it not your final answer? Because we have just reduced these two. We have not related R12 and R34. How to relate it? So just instead of the wire, replace it. Just keep on replacing. Instead of this, see, instead of the first wire, instead of that 10 ohm resistor and that 20 ohm resistor, just connect a single resistor. That is what? 30 ohm now. And instead of these two, connect a single resistor. That is 60 ohm. Now you can relate both of these. Abdullah, can you try how these two are connected now? R12 and R34? Yes, Abdullah. Anushka, can you try? These two. Parallel. Perfect. They are connected in parallel. Abdullah, see, here is a branching, no? Because this was connected to that normal battery. That's why here both of these have different values of current, and that's why we say they are connected in parallel. Is it clear to you, Abdullah? So our equivalent is what? Our equivalent will be given by 1 by R12 plus 1 by R34. So 1 by R equivalent becomes 1 by 30 plus 1 by 60. That is simply 60. Here it will be 2 plus 1 divided by 60. That is 3 divided by 60. R equivalent becomes 60 divided by 3, which is equal to 20. 20 ohm is your final answer. So had it not been a balanced switch, then we would have had this middle wire also. Then how to solve it? There's a different procedure for it. Right now, this middle wire got eliminated. Since no current is flowing, this wire is of no use to you. You can simply remove it. And just thus it makes your calculations easier. Clear, class? So this form of arrangement is known as a Wheatstone bridge. Clear, class? So note it down. Any doubts in between, ask me, I'm here. just text done in the chat box when you all have written.